Okay, welcome. First session after lunch, and we talk about testing. It's your fault. Someone voted for the session. I don't know why, but that's why I'm here. I didn't want to give a talk at DroidCon, but then there was the community day, and you could submit a session. So I thought maybe someone interested in these slides that I built for DroidCon Lisbon like a couple of weeks ago. So I hope you haven't seen this, because there's no video for it. So unless you were in Lisbon, you don't know this presentation. So if you know me, you know that I'm talking about testing. Like I used to talk about testing quite a lot. Wrote like blog posts about it, gave a lot of presentations. So at some point I thought it's over, right? I mean, we have so many testing sessions here, which is cool. But I thought there's nothing else I can add. But then people keep asking me questions like, I can't even name one, but they were very, very specific. And I always think like, but I never had this problem. Do I something wrong? Do they something wrong? Like, so I thought, maybe instead of trying to answer something very specific, how I test this specific live data from ViewModel in this area, let me show you how I do this. So I was starting a new project, and then I thought, let me just show you the steps how I'm writing tests, and maybe there's something you can learn from this. And this was the idea of this talk. I mean, I know that all of you at some point have written this book. It's very popular, I have the feeling, although it got much better, right? From the early days of Android, it was literally everyone read this book. I have talking about testing for quite some time. So I found this slide, which from 2008, BlackBerry Developer Conference in Santa Clara, California, was my first public talk about unit testing. It was for Java applications for BlackBerry. It was horrible. Probably if I would find the slide somewhere, I would hate it. But this is how my testing journey started, or at least the public testing journey. And then, speaking about DroidCon, a couple of years later, I think this is 2012, at DroidCon Berlin, I gave a talk, unit testing with Robolectric. The problem was, in the early days of Android, unit testing was impossible. For me, coming from a BlackBerry background, this was like, what the fuck's happening? Why I can't write unit tests? Robolectric solved this. But it was like Pandora's box. We opened it, and we solved one issue, and we have 5 new. So 2016 at DroidCon Berlin and Krakow, I gave this talk, unit testing without Robolectric. So how to get rid of all the mess that we created. I would have never thought that 2022, I would be on stage, and Robolectric is still a thing. It is for a couple of reasons. It also got better, and I will touch when I'm actually adding it myself. But ever since, I've been in a lot of projects, and I've removed a lot of Robolectric from tests. So where are we now? 2020. I think this tweet best sums it up. This is testing on Android as is now. You do some any on some mock, Hockey Mockito, and then you verify some call. This is how most developers write tests. And I would say, if this is how we're testing, and testing is fundamentally broken. This is nonsense, and it's very sad that we somehow reach this point and think that this is how testing is. And maybe by showing you how I'm trying to use tests, also how I'm using Mockito, maybe we can give you some idea like why I think this is broken. But let's start with some general quotes. From like, I mean, I'm talking about unit testing now since 2008, so more than 10 years. But there are people doing this for far longer than we all do, right? So let's listen to them. Michael Feathers. Code without test is bad code. Or how about this one? How do you know? This one, oh, sorry. Any code without test is legacy code. That's Michael Feathers. You've seen this is the guy who wrote the legacy code book, right? Another one, Uncle Bob. How do you know something works when you don't have tests for it? A very valid question, right? And one more, Martin Fowler. Refactoring without good test coverage is changing shit. For me, this sums it up when I talk about testing. This is not about testing. This is not a QA part. For me, testing enables refactoring. If I can't refactor, my tests are useless. If I have to remove all my tests after refactored, they're useless. So tests is not about testing for me. It's enabling refactoring. It's the only documentation that lives with your code. It's another nice thing, but this is the point. So let's talk about testing and how we do this. We all know this, right? This is the theory. We have a few manual tests. We We have a few more UI tests as a testing pyramid, and we have a lot of unit tests, right? This is how we've been learning it for many years. Probably you've seen like multiple presentations showing the pyramid. But we also know that in reality, it's like this. We have a lot of unit manual tests. We have far too many UI tests. They're all flaky, by the way. And maybe you have a few unit tests. Or we don't have any unit tests. To be honest, Android projects, if I've seen, mostly look like this. And often without even a unit test. Or maybe there's the example unit test that is there that Android Studio generates for you. I've seen this a lot. So what are we talking today? So lately I was starting on the Wear OS client for SoundCloud. I couldn't say it at Lisbon, but now it was announced at I/O. And the very first thing was this task. So I want to write a login feature. The idea is, for this first ticket, there's a login button, I click it, it opens my phone, I do like an OAuth login there, and then just say I'm logged in. So my very first ticket, this is how I started. And what I will show you in the next 30 minutes is the actual code that I've written with the actual tests. Here and there, maybe I removed a parameter from a constructor or a method if it wasn't relevant, but this is my actual code. And this is how this presentation started. I basically went back to Git and looked at my Git history and copied it over to slides. So where do we start? I did everything with Compose, was my first Compose app. So I started with a login screen. I guess I need a view model. Hilt was always set up on a project. And I put like a button there with a text. Some login status for now, but important is there's a button that calls viewModel.login. This is the first thing that I wrote. So there's no TDD. I actually wrote this thing first, but you might see that some things are a bit TDD inspired the way I work here. So let's look at the login view model next. So view model is also simple. I knew that I will have something, I called it auth operations for now. I didn't know what it will be, if it will be repository or something later. It's something that I can call login later on. But let's ignore this for now and just look at these three states. I think in the beginning you're not logged in, then you're logging in, and afterwards you're logged in. So I thought I will have these three states. I defined an enum, and I set a status, and I said it's not logged in. And you know what? We can already write a test for this, which is easy because the test is that the initial login status is not logged in. I have my very first test. With TDD, you probably would have even started with this. So very, very simple. So what's next? Let's implement the login. So what happens when you click this button, right? So let's look at this. Very simple. This is the first thing I wrote. So when I call this method, I'm setting the status to logging in. Then I do coroutines, starting coroutine here, that will call on this auth operation thing, whatever it is. It was empty by then, calls a login method. Afterwards, if this doesn't crash, doesn't throw, I'm setting everything to logged in. If there's an exception, it's not logged in. This is not beautiful code. This is not how you will write production code. But this is the first thing I did. Let's have the exception handling here. Our exception handling is print the stack trace and setting it back to not logged in. But very simple, right? And you know what? This is easy to test. So let's write so I'm using JUnit5 in case you're wondering, because I like this nesting, so I can write a story. When logging in, should set the loading status. So I'm calling test the login as a run test. I hope you have been in the coroutine testing talk. That was amazing. And yeah, I'm in the logging in status. Because I didn't do anything with the test scheduler here, so I call this method afterwards. I should be logging in. This is simple, and it's like this. We can also write a second test. So when the login was successful, so when this block finishes and the coroutine finishes, I did it in a way that I put the run test here. You can also keep it there and then do the advance until idle, so both are totally valid. But I finished the whole thing, all the coroutines are finished, and then afterwards I'm logged in. So for all the code that we've just written, we have the test. You could even do it like this. For later usage, we can move all of this into the inner block with the nested class. I like this. So whenever you're logging in successfully, which is this block, then the status is there. It looks even nicer. I just refactored the test a bit. This is the actual test that I committed. So let's do it further, right? Let's think about this authentication that we need to do. So what happens when I press login? So the way it works on Wear OS, or supposed to work, You open your phone with a thing called Wear OS remote client or something, API client. So this is the first step. So you're using an API that gives you back the token afterwards from the overflow. And then I can go from the watch to the SoundCloud backend and actually do the actual login. So it's a it's a process of 2 steps. So let's look at the code for this. So we're now in this auth operations task. We can start writing it. I realize I need a thing called the auth client, which is some interface for now, which will do the phone part. And I will have an API client, which will do the SoundCloud part. And all the login method does, so suspend, right? It says authenticate. I'm getting back some code, and I'm passing this code to the register code. The register code for token, I call the method. So this is the thing that I wrote, added these 2 methods to the interface. Very simple. We don't have to understand for now what they do. How would you test this? I don't like it, but we probably would start with just mocking this auth client. And when you call authenticate, we'll pass in some code. If you've seen my talk at KotlinConf that I gave a couple of years ago, you know that I avoid like all the primitives. So this code is not a string, it is actually class of code. If this is like an inner class for you, data class or whatever is your call, but yeah, don't pass around just strings. This is a code, an auth code in this case, and not a string. So this is the way I wrote this code. So let's look at the test. Remember, this when logging in successfully. We can add another method now. It should authenticate. So when this thing happens, I want to verify that this method is called. I don't like this. We're doing this verification mocking that I showed earlier, right? But for now, it kept me going. So let's use this. But there's a second step, right? Talking to the SoundCloud backend with this code. So instead of doing mocking, because I didn't have a good feeling there, let's actually write this API client. Because that's easy. The watch OAuth part is complex. I mocked this for now. But the other part, we can keep going. Because let's retrofit. This is public API SoundCloud. You can look it up. /OAuth/token. I want to have a I want to have a token. I pass in this code. There's some grant type, which is hard-coded. Just kept it here for documentation purpose. And it gives me back some token response, which is just some JSON that actually gives you the valid token that you can use later for logging in. So let's write the API client using this. So I pass in my retrofit interface here. As you see, I'm still not thinking about data sources or repositories here. Just, okay, there's an API client. So this method is implemented. It just calls the retrofit method, pass in this code. As I said, you can look at our public API, it's not relevant here. Pass in the code, and we get a toToken as just a helper method, creating the domain object that I need to return here. So back to our test. Remember, we had this, we had a mock. Let's mock that's interesting. I'm mocking the retrofit interface, not the API client. And then in the view model, and I think I pulled version of this, I'm passing in the real auth operation with the mocked auth client, the real API client that takes a mocked service. So it's probably not the way you're doing it. And if this feels wrong to you, don't worry. We'll talk about this. This is the way I wrote it. And then we can actually, so the real API client, we can actually write the test. So should authenticate. I verified and on the retrofit service, this thing is called. I need to verify actually these parameters. I need to make sure this is the code, remember, that the mock returned, and that this is the correct grant type. So we went all the way from the view model up to the retrofit interface, which is the last thing, right, in our call. But you know what? The best thing with this test, that it makes this test completely obsolete. This test was verifying that I call on the first thing, the authenticate, but as I verified that I pass in the correct code that came from my mock, I already have this test covered. Which means that also, I can remove this mock up there with an actually thing. I have one less mock, which is something I really, really like. I talk about this later. If you can, use the real thing, not the mock. And we'll talk about this. But this is the way I'm doing this. So let's keep going. So what about the token? Now I'm getting a token back from the backend, but I'm not doing anything with it. Remember, I called login, says I'm logged in. We completely ignored the token. So let's look at it. Let's implement it. So this was the login method, remember, right? Just login. So we don't do anything with the return value from this. So I added the code. I have problems with the display, so I have like, everything twice so they see what's going on. So there's a token now. We take it. We put it into something that we call settings, and everything else is the same as before. Wow, I implemented this part. Nice. What's next? OK, let's quickly look at the interface. Just an interface that takes a token. That's very simple, right? So let's write a test for this. I need implementation for the settings. Oh, you know, better than mocking is I just implement this interface, very simple, as a field. I call it in-memory setting. That's what it does. And the view model now takes the settings. That's the only difference that we had to do on the view model. And now we can look at the tests. So again, we'll log in successfully, right? We run this. Here's a new test method. You know, the settings afterwards should be this token. Done. There's no verify something. If I'm done, then the settings, the token should be in my settings, which is just a field in a class. But then I implemented this, and then I thought, to be honest, I don't like this. I didn't like how this feels, like adding this to the view model. So I went back and I created this thing called persisting auth operations. Remember, I had an auth operation. So I thought, maybe it's better to put it there, because it didn't feel correct in the view model for me. So this thing just wraps the auth operation, calls the login, and then afterwards sets the token. It feels nicer to me. Whenever I pass this in and someone calls login, the setting is saved. My personal preferences, I like this more. And then what we have to change in the test, we pass in the persisting auth operation, not the auth operations. Simple, nothing else. That's how it should be. I refactor something, the test did not change. I already tested that I set it a token. I don't care where. So refactoring should not lead to test changes. Maybe in a test setup, but don't touch a test. If you have to touch a test, then you lost the confidence that you're not breaking anything. Let's keep going. We have to save this token. I mean, in a moment, set an interface. By the way, I have not run the app a single time in this process, right? So let's save it somewhere and not only in memory. So I looked into this. I extracted a token storage. Probably my colleague here, they remember this one, because later we refactored this because we didn't like it anymore. But back then, it was simple. I have one interface that just cares about the token, and settings implements this. I did this because it makes the implementation a bit easier. I wanted to put it to shared preferences. Why shared preferences and not like some shiny new things? Because I want it to be encrypted, and there's encrypted shared preferences that can get out of the box. So I create a class, shared preference token storage, just implements this. It takes some shared preferences lazily, because shared preferences goes to the file system, do it lazily. And this, I left this method out. This just creates encrypted shared preferences, which you can copy from the internet. There's no magic there. More important is how we implement this, the setter for the auth token. I just open the shared preference value and put a string in here. So super simple. I like it simple. First storage was like this. Let's write a test for this. And now it's getting, you might think I'm mocking it, but I'm not. I actually looked for the main SoundCloud app because I remember, wait, I need shared preferences. I found this thing. We have a shared preferences stub already. The nice thing with shared preferences, it's one of the few classes in the Android system that is an interface. Because most of the time, it's all implementations. This is a proper interface, so we can implement shared preferences, and someone did it for the SoundCloud app. It's covered by tests even. And then all you have to do, you have to return an editor, so we have an editor stub, and just based on hash map. So I could just copy over this class, had an implementation for shared preferences I can use. So this one was already covered. So prefer stubs over mocks. Again, if I would have a mock here, I remember this discussion when we added this shared preferences stub. We had a lot of places where we mock shared preferences. But what if you change the type of something, or you use like the put string in one variation and not in some other? The implementation didn't change. As long as the get and the set use the same type, you don't have to care, right? With your mock, you have to change all your methods. But I don't care. Just make sure that you actually save the thing and read it the same way. So let's keep going. Remember this auth client? This is the thing that opens on your phone. Let's look into this. And this is where we have to call some Android APIs now. Some Wear OS Android APIs. So I create this thing called a Wear Auth client. I need some application context, and I need this thing called removed auth client, which is an API by Wear OS that you create with the context. That's all it does. So OAuth client was something like my interface, so this is my implementation of this. So very simple. And now, this is one of these APIs where what I want to do is I had coroutines, but it's a callback-based API. So all we see here, it looks super complete, but it's actually not. So we are suspending a coroutine here, a suspend function. And then I have two callbacks that I need to provide to this API. And all I do is calling the resume with the error or the failure. If you ever have a callback-based API and you want the coroutines, this is just the way to go. You can look it up. So it looks complex, but it's actually not. So we're calling one method, and we're returning the result. And the result is either the off-code response here or an exception. So very simple. So these are the three important lines. Everything else doesn't matter. So now we have to test this, and now it's getting ugly. This is a Where Was API client, and I wanted to test this because I want to make sure I'm actually using it correctly with the coroutines matching. So I needed Robolectric because otherwise it would not work. So let's go step by step. One with Robolectric. Whenever we add Robolectric in the SoundCloud code base, we should add one of those. It's a custom annotation that we have it that describes why are you needing Robolectric here. Whenever I open a test that does not have this annotation, I remove the run with and run it to see what's happening. Most of the time, it works, and I just saved you 10 seconds by executing this test. So let's look at the test, what we're doing here. So we are creating a success request, and I have also a failed one for this, where in the end you just call this, when this method is called, we are calling this callback. It looks super ugly, it's a super mocking details, right? But it's the only way I can go in here, because I don't own this API, I have to go via the mocks here. But I want to make sure that my coroutines gets the error and gets the success response. So I want to test this way. So now I can write the actually test after the setup. So I'm creating this where-of client, some Robolectric magic to get an actually application so that it works. But all I'm testing is, hey, when I call authenticate, then this code that I set up earlier is returned. That was the one that we put in the mock. Very simple test, but a lot of complex test setup. But when I have handled external dependencies, I often have to mock. I have to use Robolectric. And I'm totally fine with this, because better have a slow test than no test. So let's go back to our API. We are not done, right? There's something that I missed when testing this. We tested all the way to the Redwood interface, but I want to test some things that I normally always test. But in the meantime, something happened in the code base. The auth operation became the auth repository. I was thinking in the beginning. And then also we have an API client that we put in a proper API data source because we thought about a different data source already by then. But the nice thing is no changes in the test. Everything is fine. We just move things around. The tests were all valid. Because remember, we tested the whole flow. So let's look at our data source that we had by now. So it takes the service, implements the auth data source. Nothing to do here. So and I'm adding this to every project I've worked on so far. I took the JSON that comes from the backend and put it in the test folder, in the resource folder of my test. And I created something called the JSON reading off service, which basically just takes this JSON and returns it on your service call. Using Moshi here, and then I could create this API, the real API data source, and then could have a test like this. You know, when I call this method with some input, then I can actually see that my domain model afterwards has the proper token. So I actually also tested the JSON parsing through a Moshi, that I'm looking at the right thing. Something that I do in every project. The nice thing is whenever someone asks me, what is this response looking like? Or what if I change this one field in the response, in the JSON response? I'm opening a test folder. They're all there. I'm opening the right one. I can change it. I can run the test, and I know that will be harmless. Which sounds simple, but I've seen API and API implementations of people using SoundCloud API. If you add something in the JSON, their client will break. So you never know, right? So it's nice to have all these JSON files in your test folder and make sure that they're working, and that you can actually test if something will break. So this is something I do. So take the JSON and test it, the full cycle. And you'll probably say this is not a unit test. Wait, we'll talk about it. But we keep going. We still have a UI. We wrote this login screen in the beginning. It's compose. And the nice thing is for Compose, we can actually do testing, like unit testing. So one thing I did at this moment, I created an abstract login view model. And there's an implementation called HILT login view model. That's something I like to do. So either inspect the interface or an abstract class for your view model. I prefer the abstract class because then it is a view model when you handle it. I moved the login status there, nothing else. Just the implementation is abstract. And the initial status we could put in the abstract class already. So when you use it, this is the way you would use it, right? But I can have a stub for my test. So another implementation of login view model, that all it does, it sets the status to logged in. You could also call it successful logged in view model or something. And this is what I'm using for my UI test. So let's write a UI test. If you want to have the unit test, and we've seen it in the testing talk, either you have to write an instrumentation test, but if you want a unit test, you need Robolectric. You have the compose test rule, means JUnit4. I mean, it's Robolectric, one reason I don't like it. But no magic here. I'm creating a login view model stub as my view model. That's the important thing. And then we write, let's load the screen, which is, you have to run compose test, set content, set theme, and then show the actual, load the actual screen. This is simple, and you do it all the time. But then you can show you these nice things, and you've seen it in the testing talk on Wednesday, I think. We can have something like, so on the node with text logged in, shouldn't be. Remember, the status was on the button in my first ticket. So it's not logged in the beginning. Then I'm finding a logged in status. I click on it. Afterwards, I'm logged in. So afterwards, this status changed. This is all I'm testing here. Which means I tested the UI, the initial status, I click on it, and the status afterwards, without doing any requests, without mocking anything, because I had this view model stuff here. So I preferred Robolectric here because I could write a unit test, or a JVM test, let's call it like this. So I prefer Robolectric when I don't have to start up the emulator, which for Compose is amazing. And most of the time it works, my experience so far. So let's look at what we actually have written, and then we can discuss it. So we wrote a login screen test that tests the login screen, completely isolated. We wrote this login view model test that tests actually a lot of things. It tested the login view model, the repository, and the API data source. Then we had this JSON test somewhere here. We had a where of client test and a shared preference test. You could also move them this in. You could do the JSON test in here. It might become a bit messy. I mean, you can refactor a test, right? But this is your thing. This way. But we have some external dependencies that we are testing separate. So UI, nearly everything, and some external specific things. And now you can say it. What you're doing is not unit testing. And if you see the testing pyramid, like in the testing talk, I mean, there are many names for all these things. And you probably say, Danny's doing integration test here. So let's talk about this. So actually, like a couple of 2-3 years ago, I wrote this blog post because it came up before when we talked about TDD. And it's very interesting when you look a bit at the history of the word unit and what a unit is and what we all think a unit is. Because we all think it is isolation, right? It's a single method of a single class. And there's a really good talks that also looked into this. So if you look at the book TDD by Example by Kent Beck, he does not mention the word unit test a single time. This is kind of where unit test coming from. He doesn't mention it. They call them developer tests or test. But at some point, this urban myth, and there are like different stories where this appeared, that a unit is a method. When you go back in time, a unit to the older developers, unit for them meant a module. It's a complete different scope. But we all have these cringe when we see, wait, this is not a unit, right? We know exactly what a unit means. So what most developers do is this, right? There's class A and test 1, class 1. There's class 2, test 2. And the same with test 3. And we're testing them all in isolation because that's what we learned. I wrote tests a couple of years ago like this. But some developers don't do it. They do it more like this. You know, they have one test. Remember like the login view model test? It tests multiple classes, and it feels wrong, right? So what are these developers? These are often developers that do TDD. Because they start with a test, and they derive implementation. And like after a while, in the third step, in the refactoring step, more classes appear. But nothing changed in the initial test setup. I mean, in the setup, yes, but on initial tests. It doesn't matter how many classes are here, extract utils here and there and there. I mean, the tests are already written. You can refactor them, you can move them around. No one blocks you there, but you can also just keep them. So let me tell you a true story of a project I worked on. So we had some tests, and they coupled a view model, repository, and API. So similar to what I've showed you. We've written all these tests. And then I was working with this developer, and he was really eager to introduce something like this. Store reducer side effects. Because we really wanted to play with this. We always said, like, yeah, I know, not now. Let's call him Max. His name wasn't Max. Not now, Max. And then on one weekend, he opened a PR and he implemented all of this. And he said, don't worry, I did it on my weekend. So he introduced stores, reducers, side effect, the whole thing. So went from MVVM to this model. The nice thing is that, except of a few adjustments, all these tests were still valid. Imagine we would have written tests for this, or even for this new model. There's a store test, there's a reducer test, there's a side effect test. And someone moves to a different model than MVI, or real MVI. You can throw away all these tests. But if you throw away all these tests, why did you write them in the first place? The behavior of the system, the app did exactly the same as it did before. There was no change. We just changed the things, how we implemented this. And this was like an eye-opener for me when I realized, wait, we completely changed the architecture of the app. Well, Max did over the weekend, but the tests still work, and everything still worked. And this is what's behind this. What your code does is stable. We didn't change the app behavior. Customer side, everything is the same. But how the code does is unstable. We might do MVP today, MVVM tomorrow, MVI, and I don't know what will be the next thing. So, but should this affect all your tests? Maybe some. So think about it. So for us, this was like these tests were actually rock solid because we didn't care. Could we move all these things again, and it would be fine. So to Wolf, I came back, and he actually said this, tests should be coupled to the behavior of code, but completely decoupled from the structure of your code. And what we're doing in this thinking of how unit test works, we completely put our test to the structure of your code. And we shouldn't do this. Especially, we work in a large organization. The structure of your code will follow the structure of your organization, which is another rule of software development. But from the customer side, they don't care what's your department and who does what. So don't do it like this. So let's look back at our testing pyramid. It is everything that happens on top here is slow. We need emulators, we need devices, we need API calls, and they will be flaky. And they always will be flaky. I mean, you can remove the flakiness, and you should, but there's always some flakiness up here. Everything down there is fast and stable. So please try to move more those things that we need. Move them further up. Have less of them, and have more of the fast and stable one. As I said, you can't avoid the flakiness, but have less of these tests that might be flaky. And in the end, you get your results much faster. What does it mean? Have an end-to-end test. That's fine. You need it, right? But prefer mocked endpoints, right? Prefer Robolectric over device test if you can. And use JUnit, and if you can, JUnit 5 down here. And have a lot of this. And I'm writing apps like this. And then I know if I have time, I will write 1 or 2 espresso tests. But I've not written an espresso test in a year, probably. And I'm writing code on a daily basis. So prefer screen tests over end-to-end tests, so a single screen instead of end-to-end. Prefer mocked endpoints to real API calls. You have to get rid of all these components, right? This is about flakiness and speed. Prefer mocks and stubs over like local web servers, which is better than API call. Prefer Robolectric over the device test. Prefer JVM over Robolectric. And do you really need this in-memory database? Maybe for some of the things, more on the top. But for most of the things, you probably won't. So let's end with some of the quotes of our heroes. Ken Beck, test only if you would want it to work. If it's worth building, it's worth testing. And if it's not worth testing, why are you wasting your time working on it? So I like this one. By now, the video even loads. There's a video supposed to show the current status of Warehouse Client. So we wrote this Warehouse Client is more than login screen. We are getting there. We want to release in summer. So if you have a Warehouse device, come here or point me. And if you want to test it, you will get our master build. You will get the daily thing that we're building. You will see all the things that we're breaking, but you have early access to the next SoundCloud client on Wear OS, the first watch client that we've written. And of course, we are hiring, so looking for 2 Android developers on my team, so let me know if you're interested. And otherwise, thank you, and open to questions. I'm around. I'm not sure how much time we have. Thank you.